Okay, this is section 10.2, comparing two means. Going through here, again, I strongly advise you that you actually read the section because that helps. Remember, when you get to college, that you're not going to get a little reading guide or anything. You're going to have to get used to actually reading the book and looking at the examples to help you learn what you need to do. The sampling distribution of x bar 1 minus x bar 2 is just talking about a difference in sample means. The sampling distribution is just plotting a whole bunch of those differences. So let's say we're taking the average Chapter 9 quiz score from A Day and the average Chapter 9 quiz score from B Day and finding the difference and if whether or not they're the same. So x bar 1, maybe the average Chapter 9 quiz score, it's out at 30 points. So maybe for A Day it was a 25. And for B Day it was a 24. They were a little stressed. They had to go to a job shadowing afterwards. So the sampling the difference for A Day and B Day would be 1. If I went back to last year's group and did the same thing, I would get a different difference. And these averages could also be actual decimals. So basically, after you graph all of your possible differences, the shape should be, once again, approximately normal. The center should be centered around the true mean difference of the population, which is mu1 minus mu2. And later, when we do our significance test down below for two samples, the HO is going to say that they're equal each other, meaning that mu1 minus mu2 should equal 0. For the spread for both the interval and the test, for our purposes for a t-test, we're going to be stuck with using the standard deviation of the sample because we won't know the one for the population. So it's just the square root of the standard deviation for the first sample squared divided by n1 plus standard deviation of the second one squared divided by n2. And that's your standard deviation. So for the two sample t-interval, it's your statistic minus your plus or minus the critical value times your standard error. And two sample t-test, the formula is actually on the next page, so I'm not going to write it right now. Maybe I'll tell you in your calculators, you're going to do a two sample t-interval. Pretty sure that's how it's called. It's been a while. Two sample t-test and two sample t-interval. Intervals are down here. We don't want to use z. That's only if we know sigma from the population, and majority of the time we do not. So two sample t-interval, two samp t-int, that's how it is in the calculator, and two sample t-test, t-test. Alright, and then concept 1, they're talking about the sampling distribution of the difference between two sample means, and yada yada yada, just like before. I don't really want to get into what the sampling distribution looks like and all of that because I don't want to confuse you guys. So instead we're going to jump right into confidence intervals. We still have our state, plan, do, conclude. For the confidence intervals, you should state the parameters of interest and the confidence level you'll be using. The plan, these are conditions, which are the exact same as they were for one sample t-interval. Now it's just for two. So if we flip to the grid that I have on the back, here they are. First one, we're told that we have two independent simple random samples with independent values in each sample, or the combined sample sizes are less than 10% of the population sizes. We're also told that population is normal or a large sample size, that each sample is at least 30, or the data for each sample is roughly symmetric and without outliers, or they'll actually give you data. In which case, if they give you two sets of data, you're going to have to make two graphs and show that each graph is roughly symmetric. I know there's probably some size right now. It's not that hard though. The calculator will do it for you. And then once your conditions are met, you could go down to do your two-sample t-interval or two-sample t-test. Formula for the interval. Again, this is your statistic right here. We're still looking at t star. Only for a two-sample t, the degrees of freedom is a very complex formula. So we're going to look in the calculator. Look in calculator for value. It'll tell it to you once you run the interval. If the calculator, for some reason, if you don't have it, they usually say use the smaller sample size and use that as your degrees of freedom. And that's how to look up your t-star in the table, because you still need to look that part up. So conclude, that's in the template as well. So let's just jump right into this problem. Researchers are interested in determining the effectiveness of a new diet for individuals with heart disease. 200 heart disease patients are selected and randomly assigned to the new diet or the current diet used in the treatment of heart diseases. So we've got a new diet and a current diet. The 100 patients on the new diet lost an average of 9.3 pounds with standard deviation of 4.7. The 100 patients continuing with their current prescribed diet lost an average of 7.4 pounds with standard deviation of 4 pounds. Construct and interpret a 95% confidence interval for the mean difference in the mean weight loss for the two diets. So we've got diet 1 and diet 2. So the 200 heart disease patients are randomly selected, or not randomly selected, they're probably volunteers. But we do know that they're randomly assigned, and so we're going to make sure we mention that when we do our conditions, that they're randomly assigned, not randomly selected. Big difference, and if you write that they were randomly selected, you would get points deducted. So for the state, I'm going to say that I have information here, X bar 1, which I'm going to call new diet. So X bar new equals 9.3, and S sub new was 4.7. And then X bar current was 7.4, and then S sub current, probably just write CURR, equals 4. And then state, we want 95% confidence interval for the difference in mean weight loss for new diet and current diet. Now the plan, since I don't know that they were randomly selected, I'm going to say that 200 heart disease patients are less than 10% of all possible heart disease patients. And they were randomly assigned to treatment groups. We have at least, this is the second part, is your sample size large enough? They didn't give us data, so that means we're not graphing. And our sample size is 100 in each group, so we have at least 30, which is 100, in each group of patients. I forgot context. So with the conditions met, okay to apply the t-distribution and do a 2 sample t-test. I'm going to go to the calculator, plug in my info, and write a conclusion. So 2 sample t-test, or t-interval. Oh no. I would have caught that eventually. T-interval. So 2 sample t-interval. Enter. I've got statistics. 9.3 was my first. 4.7. Sample size. Oh no, I needed that. 100. The current was 7.4. Standard deviation was 4. Sample size 100. Sea level 0.95. Pool. Oh, we didn't talk about the pool yet. It's going to ask you, do you want to pool? Remember our p-hat combined that we did with the proportions? Well, we're not going to assume that these two groups came from the same population because we don't know the standard deviation of the population. So here's the key thing you need to remember with the 2 sample t-test. Stay out of the pool. Don't go in the pool. So say no to pools, always. So I'm going to write that down here. Stay out of pool. Stay out of the pool. Calculate. And there's our information. I'm going to copy it down. And look, see that second thing they gave you? I told they'd give you degrees of freedom. What's T-star though if your degrees of freedom is so big? You could just say it's the same as your Z-star. Or if you're not sure, just write what the degrees of freedom is. They'll probably get just, overlooked. Our luck. So, 2 sample t-interval. I have my interval. Here's my do. Is 0.683 to 3.117. Hopefully there's a bell going off in your head that that's completely above zero again, just like in section 10.1. So if we were doing a hypothesis test, we would have probably rejected the HO. And then I'm going to write DF equals 193.0645. I'm going to write T star. Let's take a look at T star. And I'm going to write those approximately little wavy symbols. And just to make sure you understand what I'm talking about with this, its degrees of freedom is 193, and we're supposed to be doing a 95% confidence interval. It only goes up to 100 and then jumps to 1,000. So if we go to 95, it's a difference of 1.984 and 1.962. I could look up T star if I really, really wanted to. Second vars, because I know some of you are actually curious of it. Let me do second vars real quick. Inverse T. Oh, it's not telling me. Darn it. I think if I put 0.975, hold on, I'm just playing over here. 193. What did I have? 193.065. Will that give it to me? Yeah. 1.97. Well, that's even more. Yeah, that works. 1.984. Okay, so what I did for T star, you don't need to do this. You could say it's approximately 1.984, or say it's less than, or equal to 1.984. However, if you go to T-int in your calculator, T-int, or inverse T, excuse me, inverse T in your calculator, that's under second vars, and you put in the tail of your confidence interval. For 95, it's 0.025. Comma, the degrees of freedom, it'll give you your T star. So that's extra information that they don't really care too much about on the AP exam. However, I'll show you real quick. You hit second vars, inverse T. I thought my catalog help was on. It is. But apparently catalog help is not helping me with catalog help isn't helping with the inverse T, because when I hit plus, nothing happened. So I'm going to put in 0.025, comma 193.065, and it gives me, it's thinking, negative 1.972. The above one up here was positive because I put in the tail 0.025 plus the 0.95, which makes up the 0.975 for that T star. So basically I was looking at from here all the way down, if this is the 0.95, this is the 0.025, together is 0.975, and that's what I put in to get this T star of positive 1.972. When I put in just the 0.025, it gave me the bottom one that's negative, T star equal to negative 1.972. Again, this is such a minor thing on the AP exam that as long as you don't write that it definitely equals a wrong number, you would be okay. They usually would have an acceptable range. What else do I need to write down? Let's go back to the test, and I hit stat, test, T-sample T-test, nope, interval, we're still in an interval. I promised that this wasn't going to be that long, and already we're long. Stay out of the pool, calculate. I can write down all that information, but pretty much I already have it all. I already wrote it all down, so I don't need to write anything more. I'm good with that. Oh, I just need to write the conclusion that we are 95% confident. This is where you go back up to the actual problem, that the true difference and again back up to the problem, the difference in mean weight loss for the two diets. That's all I need to write. True difference in mean weight loss for the two diets falls between, and then I'm going to write my interval, 0.683 and 3.117 pounds. It's not really that big of a deal. After how many weeks? They were on there for a while. New diet loss, average, nope, they didn't say how many weeks. Okay. It's not much of a difference though. So, concept 3, we're jumping right into tests, unless Dave has a question on Math Excel.
Yes.
Which one?
Number 6 with A given B. I have no idea what I'm doing.
I tried helping him.
Is that the people breaking dishes that are washing dishes?
Yep.
Okay. So we're going to switch to Math Excel. It's number 6, the one that's due this Friday if you haven't done it yet. So Dave's going to give me his info for his problem. So your bonus check here. We have 3 different people and they're washing dishes. Again, number 6 on Math Excel. And aren't they like Al, Betty, and Chuck or something like that for ABC?
I need 9.1, 9.2, 9.3 reading guides. I don't know what happens.
You just take notes in the chapter. You don't have to do the reading guides. Okay, so how many dishes does Al watch?
Al washes 40% and breaks 1% that he handles.
To 0.01, so that means he's not breaking 99. Keep going.
Betty and Chuck, they each wash 30%, and Betty breaks only 1% of hers, and Chuck breaks 3% of his.
Oh, Chuck, bad washer. So, there's my tree diagram, and I had to draw that out because the question is, what's the probability that Chuck broke a dish? If you heard, read that last line of the question, Dave.
You go to Dan's for supper one night and hear a dish break at the sink. What's the probability that Chuck is on the job?
So what's the probability that Chuck's washing dishes given you heard a dish break? So that formula, probability of A given B, was the probability of it being Chuck and broken dish over the probability of all those dishes breaking. So this is where you had to look at all the past for broken dishes and put that on the bottom, because the probability that it was Chuck is going out of all of these possible routes. So we have to do on the bottom 0.4 times 0.01 plus 0.3 times 0.01 plus 0.3 times 0.03. And then we're going to figure out that sum. Use your calculator wisely. It's only as smart as the user pushing the buttons. Be careful with it. Chuck and broken dish is 0.3 times 0.03. And that should give you the correct answer.
Well, those are the ones you have to make those crazy trees. I hated those.
Yeah. All right, so now we're going back to hypothesis test. Dave, do you want this?
Sure.
And state plan do conclude. It's over here in our nice little template. points. For some of you, this might be too wordy. I don't know. Hey, you know that flow map that's electronically made, that Emily Billings made, that's on Edmodo? Anyone want to make one for 2-sample as well? 2-sample t-test means and 2-sample proportion might give you some bonus points. But I guess you would only know that if you were sitting in the room right now or listening to this YouTube video. Do boys have better short-term memory than girls? No, never. Girls are always better than boys.
No, boys.
A random sample of 200 boys and 150 girls was administered a short-term memory test. The average score for boys was 48.9 with standard deviation of 12.96, and the girls' average had an average score of 48.4 and standard deviation 11.85. So, since we're using girls and boys, and they could be abbreviated B and G, you could write these as G with a bar over it, meaning the mean of the girls, and B with a bar over it, meaning the mean of the boys. I'm not going to do that though, just because I know some of you won't like it, and I'm the teacher, and I should keep it, more structured. So I'm going to go back over here, and I'm going to circle information. We had a random sample of 200 boys and 150 girls. So X bar boys was 48.9, and the S standard deviation for the boys was 12.96. The girls had an average score of 48.4 and standard deviation of 11.85. I'm listing all my info. Once I list it, I don't need to write it again. I also know my sample size for the boys was 200, and my sample size for the girls was 150. Hey look, those are more than 30. Aren't these problems nice to you? So, I am going to keep it simple so we don't write too many words. The HO, the HO, whatever you want to call it. Remember, you have to use mu, not X bar. If you put X bar there, the whole thing's just wrong for your state. It's the mu of the boys equals the mu of the girls. It doesn't matter if you're a boy or a girl, you have the same short-term memory. And then the alternative, they were asking if the boys have better. So is the mu of the boys greater than the mu of the girls? Now we're going to use that sample data to test these two hypotheses. So the plan, we have a random sample of 200 boys and a random sample of 150 girls. Each sample is greater than 30. Hold on, Arthur. Okay to use t-distribution and do 2-sample t-test. So jump to your calculator, start putting that stuff in. Yes, Arthur?
Wait a sec. I don't understand. Shouldn't it be 200 boys and 200 girls make it even?
Doesn't have to be even. If they are
Wouldn't that
even,
be better?
that technically yes, but they do not have to have the same sample size. Good question, Arthur. He wanted to know if these two had to be the same for us to continue. They don't have to be the same. The only time that they have to be the same is if it's a matched pair situation. So in the back of your mind somewhere, if they give you two sample sizes that are the same size, ask yourself if could be a matched pair situation, because that's where it gets a little tricky. Alright, so it's okay to use t-distribution, do a 2-sample t-test. We're going to jump to the calculator and get all our info in. So stat test 2-sample t-test. We have statistics, 48.9, 12.96, 200, 48.4, 11.85, and 150. And we want to see if the boys are greater than. Remember, if you get confused on the symbols and you're thinking too much, look back at what you wrote and just copy that little symbol in your calculator, because that's the right one. And the pool, what do we do about the pool? Don't get in the pool. Arthur whispered it. I was waiting for somebody to yell it. Stay out of the pool. Oh my gosh, look at that degrees of freedom. It's because our sample sizes were so large. So, the do, we don't have to look for T star though this time, so we don't have to worry about that. We have our T is 0.375. Sorry boys, you are not better than girls in this case. The p-value is 0.354. Your degrees of freedom, again, if they're giving it to you in the calculator, write it down. 615. We already have all the X-bar information, the standard deviation, and our sample sizes. I want to see what the picture looks like though, because there should be some cool shading going on. So I'm going back to my 2 sample T test, enter, going down to blah, 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 all this stuff. Stay out of the pool, draw.
If I may say so, I think that this is a type 1 error.
Arthur.
There's no way.
No, Arthur would be wrong. It wouldn't be, he said, if you didn't hear him. If you may say so, this has to be a type 1 error. But we're going to fail to reject the HO. And if we fail to reject the HO and you think we're wrong, we're really making a type 2 error. Haha. Good practice. Look at that pretty picture.
I tried.
Yes, but it was good practice. Type 2 error. This whole value right here is 0.354. Yes, sir.
How much notes do you want us to have for each read?
At least a half page.
Half page, I can do that. Bullets?
Sure. They're notes for you. So conclude with a p-value larger, much larger than alpha equal to 0.05. We fail to reject HO. We don't have evidence that, now go back to the problem, rewrite what they wrote. The girls had an average. Is there significant evidence to suggest that boys have better short-term memory than girls? We don't have evidence that suggests that boys have better short-term memory than girls. Done. Okay, if we look at the next page, that again is your template. We've already talked about a few times here. I kind of kept referring back to it with the fill in the blank. Notice that when you're writing things, we're talking about the true difference in the means again. And we're evidence for the ha, rewrite what it says in the context of the problem. And for obtaining the sample results of, talk about the differences that you're actually getting there. And then I also included the match pair T inference because sometimes you can get these confused. For one thing, for your matched pairs, the 2 sample sizes, the before and after, if it's a before and after situation, the 2 samples have to be the same size. Sometimes you'll have two samples that are the same size, but they're not matched pair. But if they are the same size, then ask yourself if it's possible to be a matched pair. And the big thing is that we're looking at the parameter, the mean of the differences of the two groups, and we're just plotting those differences. We talked about this in the last chapter. I just didn't give you this template, so there are slight differences in there, so please read through those. This part, or Z star, yeah, that's okay, but really you should only do Z star if given sigma, which that happens very rarely. Alright, and now here's a problem. Hey, look. It's from 2011. High cholesterol levels in people can be reduced by exercise, diet, medication. 20 middle-aged males with cholesterol between 220 and 240 milligrams of blood were randomly selected for the population of such male patients at a large local hospital. 10 of the 20 males were randomly assigned to Group A, advised on appropriate exercise and diet, and also received a placebo. The other 10 males were assigned to Group B, received the same advice on appropriate exercise and diet, but received a drug intended to reduce cholesterol instead of a placebo. After 3 months post-treatment, cholesterol readings were taken for all 20 males and compared to pre-treatment cholesterol readings. The tables below give the reduction in the cholesterol level, pre-treatment reading minus post-treatment reading for each male in the study. Now, this is not a matched pair, even though there were 10 in each group. It's nice that they gave us our statistics. However, because there's only 10 in each group, you are going to have to graph these. Notice they're asking you to compare it to a significance level of 0.01. Usually we're used to working with 0.05. But I think that you should be able to go through your state plan do conclude on this problem. Make sure that you write a graph of each one and talk about it. If you look attached, I've also included the rubric, so you can even practice scoring yourself. They have the parameters for the two different groups, the mean of Group A and the mean of Group B. They wrote out their HO and their HA, and it says identifies the correct test procedure by name or formula. Either one works and checks the appropriate conditions. And of course, this is more words than you need, but they did a dot plot. That's fine. You can do histogram, box plot, whatever suits your fancy. And then they have degrees of freedom. They didn't mention T-star because it was a test. You didn't need to. And no, they didn't draw a picture. Again, that's just a bonus part that could help you out. And then they stated their conclusion. Make sure that you show the things that they look for is the comparison to your significance level, your decision to reject or fail to reject, and then the ha written out in context, saying either you have evidence for it or you don't. Those are the three parts that they look for in the conclusion. All right, that wraps up section 10.2.